10th, lesson 5, that is periodic classification of element. Now first, what is the periodic classification of element? Why it is important? Till date, we know about 118 elements, out of which some are naturally occurring element and some are man-made or laboratory prepared element. But when we want to know about the element, we must want a proper organized way which is easy to study, which is easy to convenient, which provide all the information about the element. So periodic classification of element actually provide us a proper way to study the known element till date. One simple example is there which explain you why the periodic classification of element is important. Let us suppose you are standing in your school campus with all of your school fellows, all the students from class 1 to class 12th. Lots of crowd is there. And what is the responsibility of teachers? The teachers have to arrange all of you in a proper manner. We must pick one similar property of the age. And simply announcement is taken from the stage. All the students of age group of 6 go and sit in the class 1. All the students of age group 7 go and sit in the class 2. All the students of age group of 15 and 16 go and sit in the class 10. All the students of age group 17 and 18 go and sit in the class 12. In this way, we systematically arrange the students in the school premises. Similarly, with the element, if we kept in a particular table, then it is easy to study, to be convenient to know about the element. What we have to study in this lesson? The topic we have to go through are DOBEREINER'S TRAID, limitations and example, NEWLAND'S law of octave, limitations and examples, MENDELEEV'S periodic law, merits and demerits, with modern periodic table, description and merits, and periodic properties of element, out of which 3 topics we must discuss in this video. The first is the DOBEREINER. DOBEREINER'S step was remarkable because he was actually nearly first who was trying to arrange known element at his time in a particular manner, and he used the word TRAID. TRAID is actually a group of 3 elements. This theory or this DOBEREINER'S TRAID was proposed by Johann Wolfgang DOBEREINER in 1870. According to him, the element in a TRAID had similar properties and the atomic mass of middle element is approximately equal to the average of the atomic masses of other 2 elements. The TRAID had similar property. He is providing 3 TRAID. One is called the alkali metal TRAID, one is called the alkaline earth metal TRAID, and one is called the halogen TRAID. According to him, it had similar property. Yes, it has similar property. Alkali metal, lithium, sodium, potassium are the alkali metal. Calcium, strontium and barium is the alkaline earth metal. Chlorine, bromine and iodine is the halogen metals, halogen non-metals. Okay, so they are similar in properties. What about the second? According to DOBEREINER, must add the atomic mass of first and the last element of the TRAID and divide it by 2. You get the atomic mass of the middle element. Similarly here, add 40 plus 1 and 137.3 divided by 2, you get the mass of the strontium. Add 35.5 and plus 126.9 divided it by 2, you get the mass 79.9. So DOBEREINER was explained or provide 3 TRAIDs, but this 3 TRAIDs was unable to explain the property of all the known all the known elements at that time. That is the limitation of DOBEREINER'S TRAID. DOBEREINER TRAIDs was unable to explain the properties of all the known elements at that time. After DOBEREINER, the next remarkable work was performed by John Newland in the year 1866. That is called Newland's law of octave. Newland law of octave, octave means 8. It is totally based on the musical note. As you know that in Indian classical music, the 7 notes are there. Sa, Re, Ga, Ma, Pa, Dha, Ni. The eighth node is the repetition of the first one. Sa, re, ga, ma, pa, da, ni, sa. Sa is the repetition. According to Newland, in the English music rhythm also, da, re, mi, fa, sol, la, ti, do. It means the eighth node is the repetition of the first one. Newland explained that when the elements are arranged in order of increasing atomic mass, the property of every 8 element are the repetition of the first element just as node of the musical scale. And he gave it the name, that is law of octave. Now look at here, lithium, okay, 1, 2, 3, 4, 5, 6, 7, 8, sodium. Similarly, then potassium, all these are the alkali metal. It means Newland is somehow able to kept the known element in the periodic table or in the particular tabular manner. But some limitations are also there. Firstly, this law was applicable up to calcium only. Why up to calcium? Because after that, when Newland was unable to explain all the consequences that is given in this table. See here, he put hydrogen with fluorine, chlorine and bromine. Fluorine, chlorine, bromine are halogen. Why he kept hydrogen with halogen? He did not provide any explanation for that. This is the second limitation. Position of hydrogen along with chlorine, fluorine was not justified. One more thing, look at here. This is iron, which is placed in the 7th place, and cobalt and nickel is placed in the 8th place. He kept two elements together only to adjust his table only. One more thing, the property of cobalt and nickel is similar to the property of the iron. Cobalt and nickel are dissimilar with this hydrogen, fluorine, chlorine and bromine. Hydrogen, fluorine, chlorine, bromine are non-metal. Cobalt and nickel is the metal. But he placed cobalt and nickel with this only. This was the limitation in his table that we call the law of octave. After Newland, one remarkable work is performed by Mendeleev, and that is called the Mendelev's periodic table. In year 1872, Dmitry Ivanovich Mendeleev provided a table that we call the Mendelev's periodic table. Now look at here. What is the law for the Mendelev's periodic table? The physical and chemical properties of element are periodic function of their atomic masses. This table is totally based on the atomic mass. Must remember, students, at the time of Mendeleev, only 63 elements were known. Okay, so he was trying to keep 63 elements in the proper manner. This Mendeleev's periodic table is very much related with the modern periodic table also. So his work is remarkable work. Mendeleev provided a remarkable work. Now we are trying to study the Mendeleev periodic table. Now see, this is the Mendeleev periodic table. The two terms used by the Mendeleev is group and period. Group, when we move from up to down in row like this or column, this is called the group. Okay, from moving up to down is called the group. But when we move from left to right in the horizontal way, it is called the period. So Mendeleev used two words in the group and the period. He divided his table in 8 groups. That is group 1, 2, 3, 4, 5, 6, 7 and 8. Up to 1 to 7, he again divided his group in 2 parts. Group 1A, 1B, 2A, 2B, 3A, 3B and so on. And 8th group is actually divided into 3 parts, 1, 2 and 3. If we count separately all this number, what is the number of group provided by the Mendeleev is 7 plus 7, 14 plus 3, 17. What is the number of group present in the modern periodic table? 18. We must discuss about 18 group also. Second, the period 1, 2, 3, 4, 5, 6. When we move from here to here, this is the period. One more information that is provided by the Mendel's periodic table about the oxide and hydroxide. With the help of this periodic table, we are easily find out the oxide and hydride of every element. Let us see here. Sodium. What is the oxide of sodium? There is no need to go in the ionic state or in bonding state. What we have to do all must move here. The formula is given here, R2O. R is for the element. So what is the oxide of sodium? N2O. What is the oxide of potassium? K2O. Okay, what is the oxide of H? Hydrogen. H2O. So we are, with the help of simple formula, we are able to find out anything. Same as the hydride. Let's move here. 5. Group 5. What is the formula for hydride? It is RH3. What is the formula here? NH3, PH3. We can easily find out the hydride and oxide of any element placed in this table. Okay, now let's move. What are the merits of the Mendeleev periodic table? As I told you, the systematic study of element. With the help of that table, we must know about the element in proper manner. Okay, the systematic study of the element is provided by this table. Second, classification based on the atomic masses. That is very much important property, that classification is based on the atomic masses. Third, with the help of this periodic table, Mendeleev was able to find out or correct some atomic masses of element. For example, earlier the atomic mass of beryllium is considered as 13.5, but later on, with the help of the his table, Mendeleev corrected it, that is atomic mass of beryllium is 9 only. One more important thing, Mendeleev was able to predict the future elements. Okay, in his periodic table, he placed or he named such element which was not discovered at his time. He must write the property of that element. He must provide the places for that element. Although he don't know is that element is discovered in future or not. What is the name of the element? Name of that element given by the Mendeleev? Ika. Ika is the Sanskrit word. It means one. Ika boron, Ika aluminium, Ika silicon. This is mentioned by the Mendeleev. And later on in chemistry, we have discovered some elements similar to the Ika boron, and name is given as the scandium. Ika aluminium, gallium, Ika silicon, germanium. The Mendeleev must know about the future inventions also. That is the merit of Mendeleev's periodic table. One more important thing, the noble gases that we call the inert gases, inactive gases, was discovered later. Why it is discovered later? Because it is inactive and it is quite difficult to discover these gases. But Mendeleev have certain idea about this noble gases. So he advises, if certain elements or certain gases are discovered in future, we must have to kept in the zero group. That I told you, 17 plus 1, 18. Total 18 groups are considered by the Mendeleev. That is the property or plus points or the merits of the Mendeleev periodic table. But there are certain demerits also. First demerit is the position of hydrogen is not defined. Same as with the Newland, Mendeleev also was unable to explain the position of hydrogen. He placed the hydrogen in group 1A with lithium, sodium and potassium. As we know that lithium, sodium and potassium are alkali metal. Hydrogen is non-metal. Why he kept hydrogen with these metals? We don't know. He did not give any explanation for that. So that is the demerits or limitation. Second, anomalous pair. The Mendeleev periodic table based on the increasing order of atomic masses. But if we check it thorough, but see here, that is the transition series of group 8. Here 3 elements are mentioned, iron, cobalt and nickel. That is a drawback in Newland also. Newland separated the iron, cobalt and nickel, but the Mendeleev placed it in the same place, that is the iron, cobalt and nickel. But if the this periodic table is based on the increasing atomic mass, then what happened here? This is iron 55.8, cobalt 58.9, nickel 58.7. The atomic mass of nickel is less than the cobalt, but nickel is placed after cobalt. Why? The reason is not given by the Mendeleev. Now, position of isotope. Mendeleev's periodic table based on the atomic masses, we know that their isotopes are there. Isotopes, you know very well, you have already studied it in the 9th class. Isotopes are certain element having the same atomic number but different atomic masses. Hydrogen has 3 isotopes, that is hydrogen 1, 2 and 3. Hydrogen, deuterium, tritium. Oxygen has 2 isotopes, that is oxygen 16, oxygen 18. At the time of Mendeleev, the isotopes were not discovered. So Mendeleev didn't know about this. So this periodic table is based on atomic masses, but there is no reason given for the isotope. One more important thing, in certain places, Mendeleev placed similar element in different groups. See here, copper is placed in the 1B group, okay, and mercury, it is placed in the 2B group. Whereas the property of these two is little bit similar. Why he kept the similar element in different places? He didn't give any explanation for that. Similarly, he placed some similar element in some dissimilar element with another element. See here in the first group, first A, 1A, group 1A, lithium, sodium and potassium is there, which is highly reactive elements. You know, sodium is kept in the kerosene because of the reactivity. But he placed it with the copper, silver and gold, which is least reactive metal. Why it is placed here? There is no reason for that. So